Okay. Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. I am Arya Dhani Sucipto from Universitas Islam Indonesia. My student number is 2419114 and 004. Today, let me share my study materials about the earthquake-resistant building materials and construction methods. Background. So, the Indonesia location with is placed within the Pacific Ring of Fire creates significant seismic vulnerability across the archipelago. So Indonesia is really have the most heavy earthquake challenge. So the proper selection of building materials and construction methods is crucial for resilience of the building, and the ultimate goal is to reduce structural damage and save lives. The characteristic of earthquake-resistant materials. It needs to be high strength, reinforced concrete and structural steel provide superior load-bearing capacity to withstand seismic forces. And second one is elasticity. Steel and timber offer excellent elastic properties, like allowing structures to flex and return to original form. Then lightweight. Lightweight concrete like AAC blocks and engineered timber reduce inertial forces during seismic events. And the last thing is durability. Resistance to corrosion and moisture ensures long-term performance in Indonesia's tropical climate. The principle of ductility. It is so important in the reinforced concrete building to have the strong column weak beam principle. Like it ensures columns will remain intact while allowing beams to act like fuses during seismic events. Ductility is the ability of a structure to undergo significant plastic deformation before failure. Ductile structures can absorb and dissipate seismic energy through controlled deformation, preventing catastrophic collapse. Building weight factor is equal with this equation shows the seismic force is equal to building weight multiplied with earthquake acceleration. So the lighter the building is, uh, makes the seismic forces smaller. It reducing mass directly. If we reduce mass directly, decreases the initial forces experienced during an earthquake. So they recommend materials to reduce the seismic forces. We can use structural steel frameworks, lightweight concrete systems, prefabricated components, and engineered timber solutions. Next, construction methods for seismic resilience. Conventional methods is like inside casting with formwork, traditional reinforcement techniques. It has advantages like flexibility, monolithic structures, but the challenge is uh, it's difficult on the quality control like and longer construction time. The second method is prefabrication. It's a factory-made components assembled on site. The advantages of this method is uh, it has easier quality control, like faster construction, and then consistent joints. But the challenge is transportation logistics. It needs special transport to distribute these materials, and it has a difficult connection design. And the third is hybrid approaches. It combines methods for optimal performance. The advantage of these methods is balance efficiency and quality and cost. Like example, precast columns with in situ beams and slabs. Next, critical construction aspects. In Indonesia, we call it the BMW principles. It stands for B for biaya or cost. It contain its budget constraints, and then M stands for mutu, quality, material, and workmanship standards, and the W stands for waktu or time. It, it contains the construction scheduling. And then the NIH principles, N stands for nyaman or comfort. Then I is indah or aesthetic aspect. And then H, hijau, sustainability, impact on the environmental. Consequences of inappropriate methods. Improper method selection leads to increased costs, compromised quality, extended timelines, and reduced seismic performance. Building classifications by engineering design. In the civil engineering, we have three classifications. The first one is engineered buildings. It involves the professionally designed by qualified engineers following seismic codes. It has a proper structural analysis, detailed construction drawings, met the material specifications, and quality control procedures. It it resists to high earthquake. And the second one is the semi-engineered buildings. It partially comply with engineering standards. It has only some professional input and it has only basic structural considerations and variable construction quality. And the last is non-engineered buildings. It built without professional engineering design, such as masonry designs with bricks or a simple column and a simple beam. It is a traditional construction methods based on experience, not calculations, and no seismic considerations in this building's classification. In Indonesia, we have the local innovations such as Barataga. It placed in Kaliurang, next on the Merapi Mountain, and then Simutaga. It has a Simutaga technology, so it shows the simulation of the earthquake, like moving the miniature of the house. So it will show you how the house damaged by the earthquake with the simulation. It locally developed earthquake-resistant building technologies specifically designed for Indonesian conditions. These innovations combine traditional wisdom with modern engineering principles and performance testing include the pullover test, evaluate lateral resistance capacity, and pushover test. It assess progressive structural behavior. The results confirm significant improvement in seismic performance. Oh yeah, this Barataga and Simutaga is invented by Prof. Sarwidi. Conclusions. The path to earthquake resilience. Uh, it 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 has appropriate materials. We have to select materials with high strength, ductility, and appropriate weight, and proper construction. Apply suitable methods that ensures quality while balancing time and cost. And the ductility principles. We have to design the structures that can absorb and dissipate seismic energy. So, and the last thing, local innovations, leverage and advance Indonesian technologies for local conditions. Our ultimate goal we stand for is strong, comfortable, beautiful, green, and earthquake-safe buildings. Okay, it is the last slides. So that's it from me, Arya. Thank you for your attention. Hope this presentation will give you more insight about the earthquake safe buildings and civil engineering. Thank you. Assalamualaikum warahmatullahi wabarakatuh.